Welcome to part 2 of the tutorial for topic 5, lesson 4, factoring special trinomials. In this tutorial, we're going to look at how to factor perfect square trinomials. First, let's look at what is a perfect square trinomial. Well, a perfect square trinomial has the following characteristics. It would be a trinomial, first of all, so you have to have 3 terms in the polynomial. The first term has to be a perfect square. So it could be written as a number times x squared, and you could take the square root of the number and the variable. The last term is also a perfect square and can be written as b squared. The middle term's coefficient has to be equal to 2 times a times b. So whatever your a value was from the first term, which is the square root of the coefficient, and whatever the square root of the last term is, times it by 2, and that has to be equal to the coefficient in the middle term. So if we were to look at a general form, it would look like this. In this first general form, the first term of the trinomial would be a perfect square. This last term is a perfect square, and the middle coefficient is 2 times a times b. And we can write our answer as the square root of the coefficient from the first term times x plus the square root of the last term, and then that whole factor is squared because it would be multiplied by itself. If there's a subtraction in the middle term, then it's the same pattern, only you use a subtraction sign in your factor. When the trinomial meets this pattern, we can just use the pattern to write our factored form. However, it is still possible to factor these perfect square trinomials using the methods we learned in lesson 3, which was factoring by grouping. Okay, so let's look at some examples that can meet the perfect square trinomial pattern. In example 1, we want to factor x squared plus 16x plus 64. There's a couple methods you can use. Method 1 is just to factor as you did before, using what you learned in lesson 3. So, in our trinomial, we want to find two numbers that multiply to 64 and add to 16. Here, I have listed a whole bunch of sets of factors of 64, and we want to see which set will add up to 16. Well, we want to look at this last set. 8 plus 8 would equal the 16 that we need. So we can go back and write our factored form, our answer, as x plus 8 and x plus 8. We use the positive 8s from our two factors of 64 to fill in the factors. Because these two factors are the same, we would simplify our answer to x plus 8 squared. Now let's have a look at method 2. We want to ask ourselves, does this trinomial fit the perfect square trinomial pattern? Well, we look at the first term. Is it a perfect square? Yes, it is. We look at the last term. Is it a perfect square? Yes, it is. And then we have to find out the square roots of those two terms and decide if the middle coefficient is equal to 2 times a times b. So I've written down the square root of x squared is x, and the square root of 64 is 8. We have to decide what our a value is and what our b value is. Well, the a value is the square root of whatever number is in front of the x squared. Because there's a 1 in front of this x squared, the a value is just going to equal 1. And the b value is equal to the square root of the last term, which in this one is 8. So we look at 2 times a times b, which is going to be 2 times 1 times 8, and that equals 16, which is our middle coefficient. So this trinomial does fit the perfect square trinomial pattern. And then we can just go and write our answer then. So our answer is going to be in the form of ax plus b and then squared. And it's plus b because our middle coefficient was positive. And we just sub in our numbers. So a was 1, so we don't have to write a 1 there. Our x was the square root of x squared plus the square root of the last term, which was 8, and then squared. So I know it seems like a little bit more work to look for that pattern in a simpler example like this one, but it really does show how it can be used. We'll look at some more complicated examples coming up. But for now, example 2 is factor x squared plus 6x plus 9. When you are looking at factoring a trinomial, you want to check to see if the last term is a perfect square. If it is, then look for the perfect square trinomial pattern. 9 is a perfect square, so if it fits the pattern, our b value would be the square root of that, which would be 3. Our first term, x squared, is also a perfect square, so our a value, because there's a 1 in front of the x squared, the square root of 1 is still 1. Then we have to check. All we have to do is quick check that our middle coefficient is equal to 2 times a times b. Well, 2 times 1 times 3 would give, because a is 1 and 3 is b, 2 times 1 times 3 is equal to 6, so it does meet the perfect square trinomial pattern. Therefore, we can go ahead and fill in our answer. We're going to use the ax plus b form because our middle coefficient was positive, and we are left with a is 1, so we don't sub it in, x plus 3, and then squared because our b value was 3. Example 3 is not as immediately apparent that it's a perfect square trinomial because we have a 2x squared in the first term and 2 is not a perfect square. But we can take out a greatest common factor of 2. So if we divide every term by 2, we get 2 bracket x squared minus 22x plus 121. And what we have now in the brackets is a perfect square trinomial. X squared is a perfect square, and 121 is a perfect square, and we will find that 2 times a times b equals 22. So let's identify our a value and our b value. A value is just going to be 1, because there's a 1 in front of the x squared, and the square root of 1 is still 1. Our b value is the square root of 121, which is 11. And 2 times a times b is 22. So that is the middle coefficient. Now we have a negative here, so we need to make sure we set up our form as ax minus b squared. And that's going to be our answer. So we sub in those numbers. Don't forget that the 2 is out front still because it was a factor when we took it out as a greatest common factor. A is 1, so we just write our x there, and then minus 11, because 11 was our b value, and then squared is the final part to the answer of the factored form. Our last example, example 4, is factoring 36x squared plus 84x plus 49. Let's check that this is a perfect square trinomial. The square root of 36 is equal to 6, and the square root of x squared is x. The square root of 49 is equal to 7, so our first terms and our last terms are perfect squares. And our middle term, see if it adds up, 2 times a, which was 6, times b, which was 7, is equal to 84. 2 times 6 is 12, times 7 is 84. We can go ahead and write our answer as in the form of ax plus b squared. And it's a plus b because our middle term is positive. And we're going to have 6x this time because our a value is 6. And then plus 7 squared. Now just a note here, you could factor both example 4 and example 3 using factoring by grouping before. So in example 3, you'd have to find two numbers that multiply to whatever 2 times 242 is, which would be 484. Two numbers that multiply to 484 and add to negative 44. But that can take a while to find what those two numbers are. So if you can recognize that you have a perfect square trinomial, you can get your factored form a little bit quicker. Lastly, let's have a quick look at a word problem where we can apply factoring. So if you quick read the problem, the summary of it is that Ryan has a yard of x by x dimensions. It's a square yard with a width of x. And he wants to put a patio in his yard that has dimensions of y by y. And we want to write an expression in factored form to represent the remaining area of the property. So the remaining area is everything outside of the patio, and so we want to find that the rest of the area. So what we could do is we could find the area of the yard as an expression, and then subtract the area of the patio. And then that would equal the remaining area of the yard. So if we were to write an expression for the area of the yard, that would be length times width, or side times side for the square, and side times side would be x times x. That little dot there in the middle of the expression means times. And then we would have minus area of the patio, again, would be length times width, or y times itself, because it's a square. And if we simplify that, we get x squared minus y squared. And that would be equal to the remaining area. If we were to factor this, we can see that it is a difference of squares. X squared is a perfect square and y squared is a perfect square, and they are being subtracted. So in factored form, we would have x plus y times x minus y. And that would be our factored form for the remaining area. Thanks for watching.